Hey guys, welcome to Chapter 9 in Big Ideas. So this is about right triangles and trigonometry. We're going to start off by looking at a very famous Pythagorean theorem, looking at some similar right triangles, and then we're going to get into some introductory stuff on just trigonometry. So this is a very basic few things here on these last 9.4 to 9.7 lessons on trig ratios, and then the law of sines and cosines. All right, but first of all, just 9.1 is on the Pythagorean theorem, and hopefully you guys have remembered this before and maybe seen it before, but we'll go over it again. We're going to be using the Pythagorean theorem. We're going to be looking at the converse, which is like the reverse of it, which is actually just figuring out if it is a right triangle, and then classifying some triangles. Alright, but first let's get into a little just cartoon. This is one that I've been looking for and was one of my favorite cartoons that I've seen over the years, but I finally found it. This is birds up there talking. Hey, are you thinking what I'm thinking? I love that cartoon. Okay, so let's jump into our Pythagorean theorem. So on page 244 in your notes, you have the theorem there. It's one of the most famous theorems in mathematics, named for the Greek mathematician Pythagoras. This theorem describes the relationship between the side lengths of a right triangle. So Pythagorean theorem, you've probably seen it before, just a squared plus b squared equals c squared, or you can say c squared equals a squared plus b squared. And so that's able to, if we have a right triangle, in a right triangle, the square of the length of the hypotenuse is always opposite the right angle. And the other two sides are called the legs. So it says the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And so that's what we're going to be getting into right now. Also on page 244, we're going to talk about what a Pythagorean triple is. So you have a little vocabulary up there at the top of 244. So write this in for Pythagorean triple, that it is, I underlined this part, but really write the whole thing. So Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation of our Pythagorean theorem, c squared equals the a squared plus b squared. And the core concept, here's some common Pythagorean triples. So basically, if you have three whole numbers here, these are all whole numbers you can see, that make this Pythagorean theorem work, then that's called a Pythagorean triple. Sometimes we get numbers that are not going to be whole numbers, and that would not be a Pythagorean triple. So for instance, even just on this first one, 3, 4, 5, if we wanted to try that one, so we said, okay, 3 squared plus 4 squared, does that equal 5 squared? And it does, because you can see this would be 9, this would be 16, this is 25 over here. 9 plus 16 does equal 25. So that would be considered a Pythagorean triple, because these are all, regular just integers, positive integers. Integer means it's not a decimal, it's not negative, it's just a positive. In this case, it's positive integer. So integers can be negative, but this one's asking for positive integers. So these are just like numbers on a number line, not decimals or fractions. And so what's below them is just like if we multiply all these numbers by 2, we would get these numbers. That would also be a Pythagorean triple. For multiplying by 3, we get these numbers. If we multiply them by x, we would get those numbers, or those terms. And so these are the ones in bold here are the ones you might see most often, 3, 4, 5, 5, 12, 13. This will be the same thing. 5 squared plus 12 squared will equal 13 squared. 8, 15, 17, 7, 24, 25. These are all Pythagorean triples that you might see. Okay, so on page 246 in your extra practice, we're going to do with 1 through 6. We're going to find the value of x using Pythagorean theorem, and then tell whether the side lengths form that Pythagorean triple. So if the value of x is a integer, positive integer, then it will be a Pythagorean triple, because the other sides here that they give us are all positive integers as well. So we're starting to see is x also a positive integer. So for the first one here, number 1, we could start off by just saying we're looking for Pythagorean theorem. Let's write it up here again. So they wrote it as c squared. I like doing usually a squared plus b squared equals c squared. So I like it usually like that. That's usually always how we just A, B, and C, kind of in that way. So let's just go ahead and use that. So we're going to look at 81 squared. This will be 81 squared plus 108 squared. Does it, it's going to equal x squared, because x is the hypotenuse. It's opposite the right angle. So x is our C. So when we work on these, let's go ahead and pull up my calculator. So we know 81 squared. So 81 squared, that gives us 6561. So 6561 right there. 108 squared, that's giving us 11664. 11664 and 4 equals x squared. And so then we just want to add those together. So I'm going to say adding plus 6561. That gives us this number, 18225. So 18225 is equal to our x squared. So we have to take now the square root to find x. To be able to figure out what x equals, we need to now take the square root here of both sides. So take the square root of the 18225, which means I just need to hit the square root button on my calculator over here. 135. So x is equal to 135, which is a positive integer. So we can call this one, yes, it is a Pythagorean triple. So this one I'll just call it triple. Yes, this is a triple. So yes, triple on this one. Number 2. So x this time is a leg. So we can say 4 squared plus x squared, or x squared plus 4 squared. It wouldn't matter. I'll put the x first. X squared plus 4 squared is equal to the hypotenuse squared, 8 squared. So it's going to give us x squared plus, this is 16. 8 squared is 64. Subtract 16 now from both sides to solve for x squared. And so that's going to now give us x squared is equal to 64 minus 16, that would be 48. Now we want to take the square root of both sides. Different color for the square root. So let's take the square root there of both sides. So now we can see x is equal to, so the square root of 48, that's not a perfect square. So this means it's not going to end up being a positive integer. This one will not be a Pythagorean triple. So we want to leave this just in terms of a radical, but we do want to simplify our radical. So inside of 48, we could think of it as 16. So this could be 16 times 3. Square root of 16 times 3. And 16 is a perfect square. The square root of 16 is 4. So our answer for x will be 4 square root of 3. So there's our answer for x right there. All right, number 3. Let's see, 3x is the hypotenuse again, just like number 1 was. So we're going to see 15 squared plus 20 squared is equal to x squared. And so then we're going to see 15 squared out. We know that's 225. 20 squared is 400 equals x squared. So this is going to be 625 is equal to x squared. And now we take that square root of both sides. So the square root of x squared undoes the square there, so it gives me x now. So I need to take the square root of 625 on my calculator. Square root button. It is 25, so x is equal to 25. So again, yes, this one is a triple. It's a Pythagorean triple. All right, you might want to pause the video now at this point and try 4, 5, and 6 on your own. So you should be able to see me have done 1 through 3. You should be able to do 4, 5, and 6, no trouble. So go ahead and try those, and then play it, and then check your work. Okay, hopefully you've got 4, 5, and 6 done on your paper, and now we can just check your work. So number 4, x is the hypotenuse again. So we're going to look at 6 squared plus 10 squared equals x squared. And so we're going to get 36 plus 100 equals the x squared. 136 then is there, equals x squared. And then take our square root of both sides. So the square root of 136, that is not a perfect square. 144 is, 121 is, but 136 is in between that. So we might want to look for, what can we break this apart into. So So what perfect squares would go into 136 is what we're looking for to figure out what is x equal as a simplified radical. So for 136, you might want to try it on the calculator. We could divide it by 4. We do know that. 4 does go into 136. 34 times. Are there any more perfect squares in 34? And I don't think so. 2 goes into that, 2 times 17, and I think that's pretty much it. So really this could end up being, for 136, I'll put it over here, we could see it as 4 times 34. Square root of 4 is 2, so we're going to see 2 square root of 34 as our answer for this one. So this one's not a Pythagorean triple, that's not a positive integer. On 577 is the hypotenuse, so we can say x squared plus 55 squared is equal to 77 squared. So x squared, and then we have 55 squared. Let's go ahead and do that over here. Whoops, too many 5s. 55 squared, that's 3025. So 3025 is equal to 77 squared. It's 5929. So now we just want to subtract the 3025 from both sides. Those would cancel. So now we see x squared is equal to what we got right here. So just minus now. Minus our 3025 number. And it equals 2904. So 2904. Take the square root of both sides. And I know 4 does go into this one, but let's just check and see if it actually is. Maybe it's a perfect square. I don't know. Let's go ahead and try it. Let's hit the square root button. It is not. So it's not a perfect square. But I do know that 4 does go into that. I could try that and see, 2904. Let's see, divided by 4, because it ends in 4, so I know it's 726. 4 doesn't go into that. I don't believe 16 will go into that. I know 25 doesn't go into it. 36 probably doesn't go into that. We can try some of those. We can say, okay, divide that by 16. I doubt that because 4 doesn't go into it, so 16 obviously couldn't do it. Let's do it by 36 then, just to see. Oops, not 32. That's 726, right? Better start from the beginning. 2904 divided by 4, and then divided by 36. Does 36 go into that? No, I think it's just going to be that there. So we can say x is equal to, like I said, we'll make this into 4 times 726. So that's going to be 2 square root of 726. As a decimal, if I wanted to figure out what the decimal was, we did that already as well. So if I needed the decimal, we could. So 2904, and the square root of that was 53.9 if I round it to their 1 decimal place. So I might want to just write that down just to see. It could be that as well. So it also could be 53.9 to 1 decimal place. All right, number 6. X is the hypotenuse, so we're going to see 48. I want to do this one in a different color. I'm getting tired of these two colors. So 48 squared plus 90 squared is equal to x squared. So we got 48 squared. Let's go over here. So that's 2304 plus 90 squared. So 9 times 9, it's 81 with 2 zeros. And it's going to equal our x squared. So I'm just going to add these two together. There's too many zeros there. So plus 8100. There we go. So I'm going to get 10,404 equals x squared. And let's go ahead and take the square root now of both sides. And so x will equal, let's just see it, is this a perfect square? Square root of that, it is 102. So it is a perfect square. So again, we don't have another triple. So yes, on this one, this is a triple as well, because we got a nice, neat, positive integer on that last one. Okay, so number 7. This little word problem here. It says, from school, you biked 1.2 miles due south, and then 0.5 miles due east to your house. if you biked home on the street that runs directly diagonal from your school to your house, how many fewer miles would you have biked? So first of all, let's go ahead and draw a right triangle. Let's go ahead and draw a right triangle here. So let's assume that one of these vertices is the school and the other one is your house. So you have a right triangle on your paper here, and so let's go ahead and put the school at the top and then your house down here on this corner. So when they say, okay, you biked 1.2 miles due south, so you're from school, you're starting at school, due south would be down. So this is going to be a 1.2 here, and then you're going to go east, which would be going this direction to the right, 0.5 miles. And so we can label those then with 1.2 and 0.5. So it's 1.2 for the south here, and then 0.5 for down here. This would be the direct route, that diagonal that says here, a street that runs diagonally from your school to your house would be our hypotenuse of this right triangle. Because we know that south and east are perpendicular to each other, so they're going to make an exact right angle right there. That's why we can see this is going to be a right triangle if you have the diagonal from your school to your house now. And so that's what we're looking for. It says, how many fewer miles would you have biked? Well, we need to know how many miles this is. How many miles is it from your school to your house? So we're looking for x. We'll put x right there. So that's just going to be what we just did. So we're going to go ahead and do our Pythagorean theorem. X squared, so the hypotenuse squared will equal the 1.2 squared plus the 0.5 squared. And so now as we do these numbers here on the calculator, we're going to get x squared equals 1.44 plus 0.25. Add these two together. So now it gives us x squared is equal to 1.69. Take the square root now of both sides. And once you do that, x will equal 0.1 or 1.3. So that's a 1.3 miles for the direct route from the school to the house. So how long or how many miles is it that he did take? So 1.2 plus 0.5, if you add those together, that's going to be 1.7. So he actually did bike 1.7 miles. If he had biked this diagonal, it's 1.3 miles. And so you can see we're just going to do a little subtraction, 1.7 minus 1.3. That would give us 0.4 miles fewer then. So that's the answer there, 0.4 miles fewer, because you're answering our question. Always make sure you answer the question as they ask it. How many fewer miles would you have biked? All right, so here's our joke of the day. How do you count cows? How do you count cows? With a calculator. Calculator, of course. Okay, so on page 245, you'll see the converse of the Pythagorean theorem, and all that is that if we have a triangle here, but we're not told that it's a right triangle, but if c squared equals a squared plus b squared, or basically if a squared plus b squared does equal c squared, then we can tell that that is a right triangle. So we can basically prove or show that a triangle is a right triangle if you have kind of the legs of the triangle here, a squared plus b squared equals c squared. If Pythagorean theorem works, then you know it's a right triangle. Okay, so right underneath that core concept for the converse of the Pythagorean theorem in the notes section, which is on the top of page 245, let's go ahead and copy these two down, 4 and 5 here. You don't have to number them if you don't want to, but let's just go ahead and do this first one, where it says tell whether the triangle is a right triangle. You want to write that down as well. Tell whether the triangle is a right triangle. Copy the triangle down. 9, 15 here. These would be like the legs. Your hypotenuse would be 3 squared of 34. So what we're going to do on this one now is just put it into kind of the Pythagorean theorem. So a squared plus b squared would be 9 squared plus 15 squared. We're asking a little question mark here. Does it equal this c squared here, 3 square root of 34 squared? So we're going to do 9 squared, we know, and 15 squared is 225, so 81 plus 225. does that equal this over here? So as we square this, we're going to square 3. 3 squared is 9. And when we square the square root, that just undoes the square root sign, and now it's 34. So this is now just really 9 times 34 on this side. So does 81 plus 225 equal 9 times 34? And you can go ahead and try those on the calculator, but they do. They're both 306. So since they both equal exactly the same number, yes, that is a right triangle. We can tell that it is a right triangle. And next one over here, let's go ahead and do the same thing. And we're looking at the two smaller numbers. So which one is the hypotenuse? Is 22 the hypotenuse, or 26 supposed to be the hypotenuse? Well, the two smaller numbers would have to be your legs. The largest number would be the hypotenuse, or the C. So we're going to see 14 squared plus 22 squared. Does that equal 26 squared? That's what our question here is. 14 squared plus 22 squared, does it equal 26 squared? So 14 squared, that's 196, 22 squared is 484, and 26 squared is 676. So if we add these two numbers here together, will it equal 676? And that equals 680, so it's almost 676, but it's not equal. So 680 does not equal 676, so no, that is not a right triangle then. It was close. It looked like it could have been, maybe, but it wasn't. It was just a little bit off. Okay, also on page 245 at the very bottom, we have this Pythagorean inequalities theorem. So right here, you want to read this with me. The converse of the Pythagorean theorem, the one we just were using, is used to determine whether a triangle is a right triangle. So we're trying to figure out, is it a right triangle? It will classify a triangle as a right triangle. You can also use the theorem below to determine whether a triangle is acute or obtuse. So remember, we've classified triangles before by their angles, and there's three ways we could say a triangle by their angles, and that's right triangle, acute triangle, or obtuse triangle. So we already know how to determine whether it's a right triangle, and that is if the converse of the Pythagorean theorem works. So does it equal? Does a squared plus b squared equal c squared? Well, here's the inequalities theorem. Basically, this would say, does c squared here less than a squared plus b squared? Basically, is a squared plus b squared greater than c squared? That's kind of what you can think of it if you want to go the back way. It says, for any triangle ABC where c is the length of the longest side, the following statements here are true. So it's acute. So here's what you want to write here. This is kind of confusing with the way it's written out with the Pythagorean theorem. Basically, you can think of your if this part is greater, if this part, the a squared and the b squared, is the bigger part, then it's going to be acute. If the c squared is the bigger part, then it's going to be obtuse. Here's another way I like to think of it. For this one here, you could say if hypotenuse is less, then it's acute. So if the hypotenuse is less, then it's acute. And just think about it in terms of hypotenuse only, just your c. But if the hypotenuse is greater, then it's obtuse. So that kind of just boils it down to just looking at the hypotenuse. So if the hypotenuse is less than the other side, then it's acute. But if hypotenuse is greater than the other side, then it's obtuse. All right, let's go ahead and try some of these on our extra practice. Okay, so here we are at the bottom of page 246, almost done, just 8 and 9 now. It says, in these exercises, verify that the segment lengths form a triangle. Is the triangle acute, right, or obtuse? So we've looked at before how segment lengths would need to form a triangle. Basically, the two smaller ones would have to add together to be bigger and greater than this third one. So we want to make sure that that is true on these. So first of all, we would add these two together, these two smaller ones here, 216 plus 90. That would need to be greater than the bigger one, 234. And when you add 216 and 90, that does make 306, which is greater than 234. So yes, this can be a triangle. The segment lengths can form a triangle then. If it wasn't true, if this was smaller than this, then we wouldn't even have a triangle at all, so we couldn't even do any classification of it. We would have to just stop right there. But since this is forming a triangle, we can now figure out, is it acute, right, or obtuse? So we're going to use our Pythagorean theorem to do that. So we take the two smaller ones, this would be like A and B, and 234 would be our C. So c squared I'll put over here. So this one, 234 squared. And I put a little blank here. We figure out, once we figure this out, we'll figure out if it's supposed to be an equal sign for right. Is it going to be greater or less than for the acute and the obtuse? So as we work this out, we're going to be just squaring these numbers. So I'm just going to go ahead and square them. You would do that on the calculator, of course. So as we square 234, that becomes 54,756. 90 squared, that's 8,100 again. 216 squared is 46,656. So now we just got to add these two numbers together. So 8,100 plus 46,656. You add those numbers together, and that does equal 54,756, which is exactly the same thing on the other side. So those two are equal to each other. So since they're equal, then we can classify this as a right triangle because they're equal. A squared plus b squared equaled c squared, so that would definitely make a right triangle. And number 9 would do the same thing, 1 plus 1 here. So it's a 1 plus 1 has to be greater than the square root of 3, which it is. You can go ahead and check that just with a calculator real quick. You can say 3 square root 1.73. So yes, 2 is greater than 1.73. So that is true. This is a legitimate triangle. And so we just want to classify it now as an acute, right, or obtuse. So we're going to do 1 squared plus 1 squared and then see what it's going to be over here for the square root of 3 squared. So starting with the square root of 3 squared, I put the c on this side. And so we have square root of 3 squared. Here's my blank. So in the blank it's going to be either equals, greater than, or less than. Now remember that what I said before, if the hypotenuse is greater, then it's obtuse. But if the hypotenuse is less, then it would be acute. So that's what you just keep remembering from the hypotenuse. That's why I put the hypotenuses on the left side on this one, just so that we keep that going with just comparing it to the hypotenuse. So this is going to undo the square root. It's going to give us 3. And then 1 squared obviously is just 1. So 3 on that side. We have 2 on the other side, which 3 is greater. So it is greater than 2. So the hypotenuse is greater, which would mean that it's obtuse then. We have an obtuse triangle because the hypotenuse is greater. So keep that in mind with the hypotenuse. If you just do it this way where you do put the hypotenuse first, that way you can just go off of your sign and say if the hypotenuse is greater, then it's obtuse, but if the hypotenuse is less, then it's acute in that one. So, alright, so that concludes our lesson, our first lesson here in Chapter 9, 9.1. So go ahead and finish up the assignment, and I'll see you back in class.